Good afternoon. Welcome, everyone. We're excited you're joining us for today's webinar, showcasing peak shaving and load flexibility utilizing distributed energy resources. That's a mouthful, or DER for short. Presenting today's webinar for Insight ACS, but in no particular order, are Giovanni Polizzi, Director for Digital Energy Solutions, and John Groders, Business Development Director for Grid Innovation. Giovanni holds a degree in aerospace engineering and a postgraduate diploma in renewable energy technology. He's collaborated with the energy sector to shape utilities of the future through digital transformation and application of IoT and the blockchain. He's consulted internationally for IT systems, smart grids, transactive energy, industrial IoT for utilities, distributed energy resources, and conventional power generation. John is a power system engineer with over 10 years of experience in utility and industrial applications, specializing in distribution, modernization, and automation. He is active in several industry groups like IEEE, RMEL, and EPRI. John has an electrical engineering degree and an MBA from Colorado State University and is a licensed professional engineer in Colorado and Florida. As always, we have some housekeeping to take care of before we jump in, so here goes. This webinar is being recorded. All participants are on mute and the chat for this webinar is disabled. Should we experience any technical issues, we will work to resolve those as quickly as possible, so please bear with us. This presentation should take about 30 minutes, which should leave plenty of time for questions. If you have any questions, just be sure to use the Q&A button at the bottom of your screen and we will get to those at the end of the presentation. So now that that's out of the way, let's get to the fun stuff. John, Giovanni, you guys ready?
Yes, thank you, Delana. All right, so thank you everyone for joining us. Appreciate you taking some time and hopefully you find this informational. So before we get right into the meat, some of you may or may not be familiar with Insight ACS and who we are, so I'd like to give just a quick background to give you an idea of where we come from and kind of where we're going. So ACS, or Advanced Control Systems, has been around for over 40 years as an operational technology provider specifically for the utility industry. So much of that evolved around RTU, SCADA systems, real-time operational management. We were one of the earliest involved in distribution management and automation, including self-healing networks like Flizzr, FDIR, and we were one of the first to do that back in the early 2000s. Then in 2005, we rounded out our entire ADMS platform by rolling out our outage management system that utilizes the same real-time database. Then in the in the 2010s, we developed a standalone distribution automation platform that works independently of any operational system on the utility network. So this is a field proven at many utilities, including running Flizzr on over 900 feeders at Georgia Power. Then in 2018, August of 2018 to be precise, ACS was acquired by Indra. And Indra is a global technology vendor of both services and solutions. So Indra is a very large technology company and it's organized into two business lines. It's over a $3 billion revenue year company, has nearly 50,000 employees and spends annually over $225 million in R&D. So those two unique businesses also encompass 6 different industry sectors. So the Indra brand actually covers the traffic and transportation as well as the defense sectors. And then the Insight brand covers those 4 sectors, which energy and industry, financial services, telecom, media, and healthcare. Insight ACS, as we are now newly branded as of this year, we fall under the energy and industry portion of the Insight brand. So who is Insight ACS? So we really do cover the entire gamut from generation to all the way down to customers for, and we really are helping the utilities handle the digital transformation. So it encompasses that entire utility vertical, and it's really one of the most complete IT/OT suites of capabilities in the industry right now. As utilities are embarking on this digital transformation, data really does become the lifeblood, and Insight ACS has vast capability of ingesting that data from many different sources throughout the utility and organizing it and analyzing it in a way to increase efficiency and effectiveness of the utility. So where are we going? So our investment plan has some pretty strategic lines of activity. So under platform and analytics, as we just discussed, data becomes so integral. We have a lot of ways that we can improve the consumption and utilization of that data. Also enhancing the customer and user experience. This is certainly a focus for almost every utility. So how can we provide tools to them to help achieve those efforts? Distributed markets, certainly the topic of today's conversation with DER and DER management. It's becoming a priority, and Insight ACS is uniquely positioned to respond to these because of our background in operational technology, bringing in some IT capabilities, and encompassing some field-proven edge computing and distributed control capabilities. Asset management, as utilities move beyond or move towards more of a performance-based asset management approach, analytics certainly comes to the forefront, and we're uniquely positioned to assist with that. And then mobility, extending that reach to leverage and enhance mobile devices that most workers and utilities are leveraging these days. And then IT/OT integration. Certainly it's a buzzword in the industry, but Insight ACS is truly a culmination of this IT/OT integration. So that gives us a little bit of a background of who we are. Now let's get into some of the meat. So I will get it started and then hand it over to Giovanni. So peak load shaving. This is not a new concept. It's been going around for years. It is as more people are finding new ways of doing it. Certainly it can be leveraged further, and that's the topic of today's webinar. But I mean, we've been doing it in these different traditional ways for a long time. So feeder voltage control, utilizing load tap changers and voltage regulators, capacitor controls to moderate voltage on the feeder. And therefore, if you do a voltage reduction, you are trying to also reduce the amount of load. Certainly works really well in a constant impedance type loads, but doesn't work as well in more industrial loads like constant power. And then also there's obviously utility managed controllable loads or load shedding for like the C&I world, where some processes are allowed to be curtailed for a period of time to help bring down the overall load of that particular feeder or part of the network. Customer demand response programs, again, something that's been around since the 70s, started out as simple switch controls onto maybe an air conditioning unit. It has now gone, much more elaborate as far as, taking control of actual thermostats or offsetting some water heaters. Even we have some companies in the Southwest that are looking to control more pool pumps at certain time periods. So that's a big part. Time of use or TOU rates. Now this wouldn't necessarily be a demand response, but it is a way of trying to entice behavior to try to curtail some demand during some of those key hours of the day. Utility managed residential energy storage. So perhaps having some behind the meter like Tesla Powerwalls and having the utility being able to manage those as needed. And then there's also grid scale storage. We're seeing this as a big push in like the co-op and municipal markets where they are paying for wholesale power and they have high demand charges. They want to leverage potentially a large battery storage to offset some of those larger peaks. And then aggregators. This is becoming a very growing use case for utilities, where they are leveraging aggregators that can bring together many DER resources and leverage that for grid services. But typically each one of these resources have their own tool and their own system, and it's accounted for separately. There has been very little collaboration between programs. There's, you're operating one without really having a lot of visualization into how another one is. So that's really kind of sets the tone for where we want to try to bring this or describe this webinar today. So we're going to look at this as how can we get a unified view and manage all of these different verticals and different DER assets together. So in this slide, we are showing a couple different ways of handling peak load management. So on your left is very traditional, and for those of you on the call from utilities that are in the middle of doing peak load management, this is probably pretty typical of what we're seeing, where there's a few different ways that we can access this. Now, through the operational systems and data, so this would be your SCADA, your ADMS or DMS, you're operating your distribution devices like load tap changers, voltage regulators, as we talked earlier. But you also may have some visualization into some behind the meter controllable loads, typically a very manual process and a system-wide process where you would just call out, SCADA sees that there's going to be a high demand upcoming, and you may want to just call for, some load relief. But again, typically very much at the system level. And then when you, for some of the behind the meter customer assets, typically it's done through the aggregation of different verticals. So you may have, in this scenario, you may have some storage aggregators. You may have some aggregators that are aggregating a bunch of hot water heaters. Another one may be doing a thermostat control, a bring your own thermostat type situation. But again, oftentimes these are all their own verticals, their own systems, and it's typically a very manual process. Let's fast forward to kind of what we're going to be talking about today is how can we bring, and this is where a lot of customers and utilities are going, how can we bring all these together and manage it under a single platform? So that is what our one-site prosumers flexibility platform allows companies to do. So keeping their existing programs in place, keeping their existing systems in place, we are just going to try to bring it all together and also tie in that operational systems and data like SCADA and ADMS to be able to start coordinating this in a much more cohesive manner and allowing you to get much more out of these programs, know when to dispatch them, be able to identify which one is most advantageous to dispatch, whether it's economical or for best system performance. So this is the basis. And with that, I think we will bring up our first poll question of the day. So in just a second, you'll get a pop-up for a poll question. And we're asking those of you out there from utilities, what DER or demand response is your utility currently using to address peak load shaving? So I've put up some pretty typical ones, your customer programs, whether load shedding, grid scale battery, behind the meter battery storage, more than one of the above or none of the above. So let's go ahead and get that popped up. And we'll give some people a few seconds to answer, and then we'll take a look at the results.
It's a good way to know if people are listening. Looks like they are. We're getting quite a few coming in. I'm gonna wait for these to slow down and I will push these out so everybody can see them. All right, I think we've hit, oh no, still coming in. All right, that looks good. Here come the results.
Okay. So the majority is none of the above. So we have a lot out there that are not leveraging any. And then also there does look like there's quite a few that do have some customer programs. No behind the meter storage, interesting. And then there's a handful that are doing more than the above, more than one of the above. Okay, great.
All right.
So with that, I'm gonna turn it over to Giovanni, and he is going to discuss the functional characteristics of this platform.
Thank you very much, John. Thank you very much, Delana. And thanks to everyone for being here, for participating in this. I know we have quite a number of participants, so really excited to show you our thought about the platform, how the platform is developed, and how the platform will develop. So first of all, we're trying to understand what after John was showing you, there's a number of vertical aggregator, a number of system connected directly to the platform. So which are the functions that we see as macro functions? So the new approach includes the possibility under one single solution to monitor load, to forecast, schedule, and perform load management, to have the visibility of costs involved in each load management event versus the cost of not hitting the load reduction targets. And lastly, to have means to reward participants. So within this 4 macro functionality, there's a lot of underlying details that we shall see in the following slides. But it is important to indicate that whatever new solution a utility may think of, the existing technology is a legacy that must be considered from the very beginning of the project. And said this, okay, let's move into one of the four components, load monitoring. So overall system load is generally measured by meters at substation and aggregated within the SCADA of a utility. So these meters, and in general, the SCADA is, of course, is real time or near real time. So therefore, a limited number of points, but each point adds very impactful information to the overall information that the platform manages. As we move towards the customer consumption point, data becomes more granular, so a larger number of points. Timescale becomes longer, as for example, for smart meters, every 5 minutes, every 15 minutes, every 30 minutes. Each data point becomes less relevant from a system point of view, but very relevant thinking about a localized effect of power delivery. And we'll see this in the following slide. So monitoring load requires interfacing different data streams from SCADA to the customer consumption point. And so having the visibility and of all the possible options for a utility to perform load management generally requires some capacity to forecast in the forecasting load, capacity to schedule with some level of certainty a few load management actions using the available resources, the function to send dispatching commands to the resources involved in each load management event, and then again, what we have just seen in the previous slide, the possibility to track every load management event as it is executed. So during the performance of the load event. For example, forecasting at system level requires a few measuring points and inputs from historical data and from the expected weather condition. So as the utility desires to forecast at substation or feeder level, the number of measuring points in applicable condition increase significantly, and the models become more prone to errors. Similarly, the models require a much shorter time frame, looking at very rapidly changing conditions, especially where highest the penetration of electric vehicles or DER. The relevance of data is evenly distributed because load management resources are evenly distributed in the network at all voltage levels. At customer level, one single supply point may not have such a high relevance from a technical point of view, but it definitely has a very important relevance from a customer engagement perspective, as we will see in the next slides. So we now switch from technical perspective associated with grid assets to a market perspective, in which we have the traditional energy markets, the conventional new contracts with customers, so residential, commercial, and industrial, and the new transactional markets. So first of all, a brief note on the transactive energy markets. Although not yet deployed, transactive energy markets are already appearing where the utility is allowed and able to procure energy and services that dynamically adapt to grid conditions. So in this case, the utility may engage an aggregator or directly a customer. This is slowly but steadily happening in countries such as Australia, where customers in microgrids provide services to the outer network and share resources within the microgrid. Going back to a scenario closer in time to our reality, customers are already engaged in load management initiatives, as John was mentioning before. They basically try to displace load out of peak hours, try to reduce overall consumption with increased efficiency, incentivize the participation to demand response events, and promote the use of energy storage. So from a platform point of view, the relevant parameter to look at is the number of transactions and the cost of each one. So this occurs because the contracts become more specific of things like the type of load management initiative, the localization of the customer or the DR, the capacity of each resource to store energy or to provide energy, and the time frame in which this can be performed. Once a load management event has occurred, the participant generally expect to be rewarded according to the condition they have normally subscribed to in contract. So traditional markets have very well established business models and routinely issued contracts, whereas at customer level, the rules of engagement can be variable within one or more regulation framework. This is what we are used to see today. These are generally implemented in the customer billing systems of the utility and associated to measures of the revenue meters. With more dynamic markets than what we're seeing coming, and with the DR becoming more significant in terms of volumes and effect on the network, we think that the traditional contractual models are going to be changed. So new rates will probably be approved and rebates will be associated to more flexible pricing. Customer will start to see a greater value of their DR, especially balancing generation and storage with electric vehicles. We do not expect customer to be constantly looking at their phones for the latest offer from the utility. We do, however, expect contracts to become smart and work autonomously with a framework of rules of engagement. If the settlements are going to be supported by technology, for example, as the blockchain, is yet to be seen. We don't know, but it looks like it could be one of the technology, but it's one of the feasible alternatives. What is more important, however, is the expectation that the financial reward may not be the only possible way. In high demand scenario, we might see customer being interested in prioritizing their need at a cost rather than receiving a reward. The platform, rather than receiving a financial reward. The platform of today must be able to flexibly adapt to this coming future. And here I pass again the word to my colleague, John, because we have another question for you.
Okay, so again, now obviously there's going to be some here that probably are going to answer 0, but what is the percentage of customers that you currently have enrolled in a demand response program? So I've given a few different ranges of percentages, so let's go ahead and pop it up and give you a few seconds to respond.
All right, just watching these votes come in. Got an interesting mix, it looks like. Still got them coming in though, so just give it a couple more seconds. All right, that looks pretty slow. Here come your results.
Okay, so as expected, majority say 0. So I would imagine that's something that may be beyond the future roadmap, but then it looks like it's Delaney, you're averaged out accordingly, but certainly the majority, it's under 5%. So, okay, good to know. So with that, I'll turn it back over to Gio to wrap us up.
Thank you. So I think it's an indication. So there is, of course, there is a lot of megawatt of demand response out there in the network. We see from the information that the Department of Energy issues, and there's a growing need for what, for example, John was mentioning before, the non-wire solutions. So how do we go from monitoring load to engaging customer? So again, we're talking about the platform. So the platform needs to have some functionalities, which we have summarized in these 5 pillars. So we have then seen which aspect must be taken into consideration when approaching the load management platform. That's what we have seen. And it is of course possible to just look at monitoring, for example, the first block, leaving everything else to manual handling for the sake of simplicity in a platform. Very soon, however, the number of events to be managed and the possible resource to be used add enough complexity that require a more comprehensive solution. So let's look at the different components of a load management solution. Monitoring, so interfacing to SCADA, to the connected resources, and to the aggregators. The utility will want to monitor the asset as well as the participation of its customers. Dispatching, from load reduction to load displacement, to load increase, or to the use of localized storage. All of these are scenarios to consider within the portfolio of load management initiatives. Interaction with the traditional technical system like SCADA or DMS must also be considered for the safety of the whole system and customers. Data analysis, managing data from very different resources still requires a data analytics engine capable of storing, organizing, processing, and visualizing information. Access to the system is most likely required to individuals that are related to the organization, but not part of it, as well as customers. So the ease of use, customization of the interface, together with robust robust user profiling becomes paramount. Optimization, balancing the best possible outcomes in terms of load with the most convenient, requires considering an ever-growing number of variables. From contractual agreements to the physical effects of each source on the network, so from the readiness of each resource to the duration of their participation, for example, energy storage. For instance, firming in renewable generation by means of storage or controllable loads may soon become an established practice for communities that share large solar PV installation, and it will require to be financially accounted for. The last pillar, engagement, feedback to customer and to the communities, seamless enrollment of additional services based on monitored data. All the above support steadily growing interest for load management. And this normally requires flexible and openly available interfaces, the use of standards for information, a solid communication and notification functionality with dashboards, and the use of KPIs. So what would a user interface look like? So when we look at an application of this kind, we could have, for example, a dashboard. In this case, this could be an applicable dashboard we can look at. So here's where we see the ongoing situation with the number of engaged resources, the number of monitor signals, a summary of the monthly operation, past and future, and the KPIs of performance. Please note that the KPI also consider the acceptance ratio as an indication of the appeal that the offers present to the customers. So on the table you see up there on the left, the user sees the relevant event that the system captures or generates. Another, this is a more operational window, gives the situation past and future during the day and allows the operation to plan, monitor, and plan the new load management events. Again, another operational window. For example, this window, there is 2 requested load reduction events planned, one at 12 p.m. and one at 6:30 p.m. So this might as well be 2 requested localized demand response events. So only interesting a portion of the entire network and not the whole system. So an example could be a neighborhood with high EV penetration, or a neighborhood with high PV penetration and a sudden cloud coverage moving towards that area. Another screen would show the summary of all planned events, right? And the level of coverage in terms of accepted offer for each of them. Requests are sent out to the participant, but they are not always matched with sufficient availability. And the operator will have to use more appealing offers or other backup solution at a higher cost. This is a summary of monthly operation with the underlying cost structure, very useful to understand where it is possible to minimize cost, and so to structure offers that they become more appealing to the customer. And lastly, this could look like from a control center point of view. There's a notification that in part of the network there is a need for a load management event, basically to reduce load in a particular event. This is a forecasted event, right? So a request is sent out. A request is sent out to a number of participants. Once the offers are received, the event is scheduled. And once the situation occurs, once the time comes and the monitor conditions require the event to be launched, then the event is launched. And the resources are used basically, and the load is reduced in that particular area, and we avoid the contingency in that particular area of the network. And here I can stop. I think we are still on time with our schedule. So I pass the words on to John for there is some question on.
Yeah, we've had some questions going in, and before I will say that if anybody is interested in learning more, obviously this is just a very broad overview of some of the capabilities, but I encourage you to reach out to the various sales contacts within Insight ACS with any additional questions that you want offline. But with that, feel free to keep submitting your questions using the Q&A box, and we will get as many of them answered as we can. So with that, Giovanni, I'll let you have the first one. Can these solutions also manage grid scale batteries?
Yes, definitely. The solution, one of the point is to manage a grid scale batteries. For example, this typically would be like the first implementation that a utility may go through, because it's directable, controllable. It's we can connect directly to the inverter or the battery, and then see immediately the effect of the battery in a particular area of the network. So the answer is definitely yes.
Okay. Another one is, do these platforms send commands, or can they send commands to the DMS and or SCADA?
Yes, in one of the slides we're showing exactly that. So the number of industrial protocols already embedded to communicate with SCADA, like ICCP or DMP3, for example, and that would be one of the things. Although we would start, for example, by receiving information from the SCADA. I mean, SCADA is a very critical system in a utility, so maybe utility is more comfortable to just have the SCADA receiving data, and then there is a proposal for example, for a switching, and in that case will be the SCADA operator operating it directly. Ideally, we take the SCADA as one of the data sources.
Okay, fantastic. Another one, is this product or solution available now?
This product is available now. We have implemented it in a number of projects in Australia. We've implemented in Spain, in Colombia. We have the monitoring part very well developed. The part that we've seen today are, of course, depend a lot on the interaction with customer and how customer want to have. That's what I was showing the dashboard, saying that this could be the dashboard in the sense that maybe customer want different information, but the power of the platform is that it's very customizable. Okay,
fantastic. This next one I can try to answer, but just very simply, is this platform a DERMS? I always laugh at that because if anybody had walked through Distributech the last few years, pretty much everybody can say that they have a DERMS system. So DERMS is just very, very loosely defined in the industry. Basically, anybody that is managing a DER, a lot of people are considering it a DERMS. So when I usually get that question from a customer, I usually come back with a question of myself is, well, what are some of the use cases? Are you, first of all, talking about, using DER as a grid service? So you're using it and it probably need to be integrated into like a DMS or distribution automation functionality? Or are you looking at it more of, hey, I want to aggregate a bunch of programs or aggregate a bunch of resources together and use them as a larger resource? So depending on that, that really can kind of shape exactly what a DERMS is. I'm actually a member of the IEEE DERMS working group, and we're trying to come up with a DERMS guide, not necessarily a specification, but just a guide to help the industry. And it's been quite the task to try to bring in everybody's viewpoint on what exactly a DERMS is and what it should be. So very much should be driven by what the use cases are. And then from there, certain solutions can be developed or arrived at. Okay, so the next one is, we do not have DER, but want to control load. How can this platform help that?
Sorry, can you repeat that?
We do not have DER on our system, but we do want to control load. So how can this platform help that?
Well, again, yeah, the presence of DER is just another variable of that the utility may use. But ideally, if there is a number of there's already a number of applications that control load, for example, controlling thermostats or controlling water pumps or water heaters, and that information is can be passed through the platform. Then the platform can definitely be used for just to control loads in the grid. One of the slide that you were showing, John, was actually showing that the idea is that whatever is already in place can be leveraged and used. So it will be the case to study what loads are controllable today, and if none are controllable, then we can bring in the edge component and connect to those loads and bring that information back into the platform.
Okay. Next one, I think we've already pretty much answered, but where have you deployed something like this? I think you had mentioned a handful of places that do have parts of this platform deployed.
Our most complete implementation is probably in Australia. Very large campus, so big as a city, and we're basically controlling the solar panel. We're controlling the largest behind-the-meter batteries available in Australia. We're controlling building automation systems, and so everything is monitored and everything is controlled. Of course, we are having interface with building automation system, for example, to control load, to set points in case we want to decrease loads. Same thing for the battery, same thing for the solar panels. And we're also interfacing the electric vehicle charging infrastructure within the campus. So a very big project sponsored by the Australian government, and there's a number of information in the web about articles that have been written. It's a project that's been going on since 2018. So it's reaching its final goal in this day. I think it's in October this year. So very, very proud of that one. We also have implemented the monitoring portion in Colombia across a number of buildings in it's the agency for training. So a number of training institutions have this platform to monitor all their loads. So again, building automation systems and direct loads, and the implementation of energy efficiency measures, and the effect that the energy efficiency measure have over the overall savings, overall loads of these buildings.
Okay, fantastic.
Yeah.
Somebody else noticed that there was noticed the Intel logo on a couple of your slides. Do you want to just talk a little bit about the collaboration with Intel?
Sure. So the collaboration with Intel is very, very, very critical in this solution. We've been working with Intel for a number of years now. We started to develop our edge component capacity, so the capacity to bring processing at the edge very close to the loads, to the physical world where we connect. And collaboration has been developed across the entire platform. So we do rely on Intel-based technology, on gateways. This is a market-ready solution by Intel, so it's in the marketplace. And we're still working with them not only for the behind-the-meter asset, but also in front of the meter. We just published an information about our collaboration with a big utility in Spain, actually in Europe, and also in so it's Iberdrola, so it's pretty much in Europe, in Latin America, in the US. For example, we're doing the smart substation in collaboration with Intel. So it's a very strong collaboration that we have to be working on for a number of years now. Very, very satisfying, very exciting times are coming.
And one thing I'll add is certainly they're a great partner to work with when we're looking at different pilot programs. They can certainly help and offer some assistance with trying to identify and come up with strategies for doing various pilot programs. So the next one, this one's a little difficult. So Gio, I'll do my best, and then you can also, in your opinion, what is the best approach for load shedding? I guess my opinion would be all of the above. I mean, really, it's trying to leverage all of your different assets. I mean, each one has some inherent, pros and cons and some weaknesses, but that's really what we're driving at with this platform, is to try to encompass all those together and then let the platform do the analytics and let you know which load shed is the best option at different times. Gio, if you want to expand on that, or offer your opinion.
Yeah, so good questions. Of course, if we're talking about a system level and we want just to reduce overall load in the system, a platform that can send out a signal and basically use every single possible application to reduce load, it's the way I would go, because we're talking about a volume of reduction. However, when we have localized effect, we have congestion in the network, we have a feeder which are overloaded, then we need a more precise action. And that's where we think a platform has to have that capacity to split between overall system load shedding and specific localized load shedding. We're seeing with the customer we are talking to, we're seeing that the ones that already have consolidated demand response or load shedding application are seeing a more localized effect or a more frequent need for load shedding. And in this case, probably a more interactive platform is the way we to support that kind of business.
Okay, very good. Well, that is all the questions we have right now. So if there's any other questions that come up or that you guys want to answer or get answered, reach out to your various contacts on the slide there. And with that, I'll turn it back to Delana to wrap us up.
Thanks, John. I just want to thank everybody for joining us today. And I do want to take a second to remind you that we do have 2 more webinars coming up in the near future. If you want to mark your calendars, Wednesday, July 8th, we've got one on ADMS, an integrated platform for enhanced operations, outage management, and delivery optimization. Then on August 19th, we've got one on Rise of the Prosumer. Those are both going to be at 3:30 Eastern time, and you can find links to register for either of those on the events page of our website, which is acspower.com, or if you're a customer on the line, you can also find those links inside Community. Thanks again, everybody, for joining us. Have a good afternoon.